Okay, an electron with speed of 6 exponent 6 meter per second enters a uniform. What is uniform? Okay, spelling, just grammar mistake. A uniform, a typo. A uniform magnetic field of strength 0.82 Tesla perpendicularly. Okay, this one he says perpendicularly. It means is talking about between the speed and magnetic field. Yeah, between the speed and magnetic field. Okay, so perpendicular, that means you say the V and B is perpendicular. We know that we already know about this. Okay, V and B if perpendicular, that means the theta is 90 degree. Yeah, the theta, yeah, here the theta refer to the theta over here. Theta over here. We are going to use this question is more about force. Okay, so it's a force on electron. Yeah, electron is a moving charge particle. Yeah, so this question is force on moving charge particle in uniform magnetic field. So it's about this formula. Yeah, F equal to QV cross B, or F equal to QVB sin theta. Okay, maybe we write down the formula here first. Okay, so we're going to use is focusing on magnetic force. Okay, which is QV cross B. Okay, or BQV sin theta. Okay, and because this is between V cross B. Okay, between V cross B, so the theta is angle between V and B, because it's V cross B. Okay, theta is between V and B. So because you say V, the speed V and enters a magnetic field, okay, between V and B perpendicularly. So that means V perpendicular to B, so theta is 90. So this one is sin 90. Okay, sin 90. Let me write down. Yeah, so it's BQV sin 90. So and then sin 90 is equal to 1. Okay, so I think you can find the force acting on the electron. So it is an electron charge. Okay, electron is a negative charge. Okay, negative charge. Negative charge. The charge okay, the charge is 1 electron charge. Okay, electron charge. Actually, electron charge you can find in the list of constant. You see that? Electron charge can find list of constant 1.6 exponent negative 19 coulomb. So I think we also got the value over here. Electron charge is 1.6 exponent negative 19 coulomb. This, if not given in a question, you can find this value in the list of constant, yeah, provided. Also, the mass of electron, provided in the question. If not provided in the question, you can find this value in the list of constant also. List of constant has the electron charge, has the mass of electron, has the mass of neutron, has the mass of proton, even mass of deuterium. Okay, so you can find the mass of electron over here, 9.11 exponent negative 31 kilogram. Okay, so we have the mass of electron also. Okay, so the V and B value also given. I think you can find the value of magnetic force. So the B is 0.82 Tesla, multiply the charge of electron, which is 1.6 exponent negative 19 as given in the questions. Okay, and then velocity is 6 exponent 6. 6 exponent 6. So I want to calculate and see. 0.82 multiply 1.6 exponent negative 19 multiply 6 exponent 6. So the answer is 7.872 exponent negative 13. 7.872 exponent negative 13 Newton. That's the force. Okay, is that correct? That's correct. That's the answer. Okay, mark it. Yeah. Did he mention about finding the? Okay, wait a second. Okay. Okay, never mind. Later I will add one more question asking about direction. Okay. Let us continue first for question 2. What is the acceleration of the electron? Okay, the question wants the acceleration. Accelerations. Just now, question 1 is about magnetic force. Now this one is asking about acceleration. Okay, what I can say is this acceleration. Acceleration. This one he say. This one will be the centripetal acceleration. Okay, because he can say he enter the magnetic field perpendicularly. Okay, perpendicularly. That means, okay, let's say the magnetic field like this. Okay, I'm going out of the page. Let's say magnetic field going out of page. Going out of page. Let's say let's say. So okay, this is our positive charge. Oh no, it's an electron, right? Electron moving this direction. Okay, B and B are perpendicular. So you can see you will have a magnetic force. The magnetic force will be, if I use right hand rule, I can find the direction of magnetic force. Let me show try first. Velocity that way, magnetic field going out of page, magnetic force is going upward. Magnetic force is going upward. Okay. The magnetic force become the centripetal force. Become the centripetal force. So once you have the centripetal force, it is the centripetal acceleration, because that's the only force. Magnetic force is the only force acting on this electron charge. This is the magnetic force become the centripetal force. So the acceleration acting on electron is the centripetal acceleration. Okay. Or I can write it this way. The resultant force acting on this electron. Okay, on this electron charge. Let me write. Okay, the resultant force acting on this electron charge, okay, equal to Ma. Okay, in this case, it is it is the magnetic force, the only force acting on this electron. Okay, mass of electron Ma. Okay, but this one will be equal to Fc. The magnetic force become the centripetal force. Understand? Become the centripetal force. And since this is a centripetal force, okay, since it's a centripetal force, so the acceleration is centripetal acceleration. Okay. So can we find the centripetal acceleration? Yes, you can. You already have the magnetic force. Yeah, BQV sine theta, isn't it? Okay. BQV sine 90, yeah, equal to MAC. Yeah. So this one is 1. Sine 90 is 1. BQV already got the value, isn't it? BQV already got the value 7.872 exponent negative 13. Put it over there. Yeah, put it over here. Exponent negative 13. And then mass of, this is the mass of electron. Mass of, mass of electron. Mass of electron charge. 9.11 exponent negative 31. Put it over there also. 9.11 exponent negative 31, and then centripetal acceleration. Okay, so what is my centripetal acceleration? Okay, 7.872 exponent negative 13 divided by 9.11 exponent negative 31. Okay, so it is 8.64 exponent 17 meter per second square. Oops. Okay, that's the answer. Am I right? Yes, 8.64 exponent 17 meter per second square. That's correct. Okay, very simple. Okay, just remember that the magnetic force you got here 7.872. This one is the centripetal force also. The magnetic force is the centripetal force also. So this value 7.87 is also the centripetal force, and centripetal force equal to MAC, and then you can find the centripetal acceleration, which is this one. Okay, so I got it. Yeah, the answer. Now question 3. Yeah, let's do question 3. Question 3. What is the radius? What is the radius of the circular path traveled by the electron? What's the radius? So this one you use the formula, you know, you use the formula FB equal to FC. FB equal to FC. So we know that you can continue here. PQ sine 90 equal to mv square over r. Okay, this one is equal to 1. In the end, you get this mv over bq. You can get this value over here, or you already got the centripetal acceleration, so you don't need to do this mv over bq, mass of electron, velocity, magnetic field, charge of electron. You can find the radius also of circular path, or you can straight away from, since you already got the centripetal acceleration, you can just do it from here. You can also, you know, your AC, let me write, yeah, your AC equal to V square over R. Yeah, because this you know, here this one is V square over R over here, V square over R here is the AC, understand? MAC, AC is V square over R, V square over R. So you can also find radius from here, you know, you got the, so you can so your radius is V square over AC. Okay, so so what's your V? What's your V? Let's find out what's your V. V is 6 exponent 6. So put in the value 6 exponent 6. Your AC value, this one got square. Got square. AC value is 8.64 exponent 17. Okay, so what's the value? Let's calculate. 6 exponent 6 square, and then divided by 8.64 exponent 17. The answer is 4.1. 4.1. Excuse me, I have a bit flu doing this video. All right. Okay. Now it's a challenging time. Everyone should be aware of. All right. So 4.17. Okay, 4.17. Exponent negative 5 meter. Okay, so that's the answer. Am I right? 4.17. Yes, I'm right. Yeah, 4.17 exponent negative 5. 4.17 exponent negative 5, 4.17 exponent negative 5 meter. That's correct. Okay, that's the radius. Okay. So if you use this method also, you surely get the same answer because it's the same thing. Yeah, same thing. Just I do the simpler method lah. Okay, I want to add one more questions. Yeah, I want to ask about directions. Yeah, since this is a negative charge electron, is a good time to ask this question. Okay, what question I'm going to ask? Okay, the fourth question is, let's say the magnetic field is going out of page. Okay, let's say magnetic field is going out of page. All right. Okay, so what is magnetic force? What is magnetic force direction? What is the subsequent path of the electron? Subsequent path. So I want to know about this. Maybe I should put this question over here. Okay. So this is the thing I want to know. Yeah, I want to know. Okay, so this is my question. Let's say the magnetic field is going out of the page. And what is the magnetic force direction? What is the magnetic force direction? I think not enough. I should write okay, what is the magnetic force direction? Okay, and what is the subsequent path? What is the subsequent path? Let's say the charge is moving. Let's say initially the velocity is moving to the right. Yeah, velocity is moving to the right. Let's say lah. Yeah. Let's say the velocity is moving to the right. Okay. Initially, yeah, this initially. Okay, the charge is moving initially. Initially, the charge is moving to the right. Okay, is initially charge initially moving to the right. That's the direction of velocity. Magnetic field going out of page. What is the magnetic force direction? And what is the subsequent path of the electron? So electron is a negative charge. Okay, so now I want to know, yeah, about this. I want to know about this. So let me okay, how do I get the magnetic force upward? How do I get magnetic force upward? I'm going to show you. So okay, let me draw first. Okay, this is the magnetic field going out of the page. Let me draw it out first for you. Okay. Okay, so I have drawn already. Yeah, a magnetic field going out of the page. Magnetic field going out of the page. Initially, charge moving to the right. It's an electron charge moving to the right. So what is the magnetic force direction? Okay, so we use our right hand rule. The finger is the velocity, the palm is the magnetic field, so the thumb is the magnetic force. But this one is an electron charge. Electron. This one is about electron. Electron is a negative charge. Electron is a negative charge. Negative. Okay. So if electron negative charge, the force is opposite, the magnetic force is opposite the thumb, not follow the thumb. Okay, for electron negative charge, the magnetic force is opposite the thumb. Okay, so now I'm going to show you. Okay, let's look at me. Yeah, now you look at me. Okay, yep, here I have drawn already. Okay, this one. Can you see that? Yeah. So this is the magnetic field going out of the page. Yeah, magnetic field all going out of the page. Electron charge initially moving to the right. So what is the direction of magnetic force? Okay, again, you use our right hand. The finger is the velocity. The palm is the magnetic field. Okay, and the thumb is the magnetic force. But this is an electron charge. This is an electron charge. Negative charge is opposite the thumb. If positive charge, the magnetic force follow the thumb. If negative charge, the magnetic force opposite the thumb. Understand? That's important. For electron, the magnetic force is opposite the thumb. Okay, not follow the thumb. Understand? Okay, good. Now look at this one. Yeah. So okay, velocity is the forefinger. So my forefinger should point to the right. My forefinger should point to the right. And then my the magnetic field is going out of the page. So my palm, it should point going out of the page. So my velocity to the right. My palm should going out of the page. Okay. So now my position of my hand is correct already. Velocity to the right, magnetic field going out of the page. My palm is showing out of the page. So look at my thumb. Where is my thumb? My thumb represents the magnetic force. Okay, my thumb representing the magnetic force. Where is my thumb? My thumb is going down, isn't it? My thumb is going down. But this is an electron charge. So for electron charge, the magnetic force should opposite the thumb. Okay, it should be opposite the thumb. That means it should actually go this way. Magnetic force should go upward instead of downward. Opposite the thumb. Understand? My electron should the magnetic force for electron. The magnetic force is opposite the thumb. So my magnetic force is upward. Understand? Velocity to the right. Magnetic field going out of the page. My palm showing out of the page. So my thumb is downward, but this is an electron charge, negative charge. So my magnetic force is opposite the thumb. So it's going up. Instead of going down, it should be going up. So I got already. The magnetic force is going up. Understand? Magnetic force should going up. So this charge should curve upward. This one become the centripetal force. Okay, center of circle is over here. Understand? This is the because this force is 90 degree to the velocity. So this one become a centripetal force. So this electron will move in a circle. Understand? So okay, that's all for this part. Wait, hold on a second. Okay, let me show you. Let me draw it again over there. So we reach a conclusion that the magnetic force is actually going upward for this one. Magnetic force is going upward. This magnetic force become the centripetal force. So the center of circle is over here. So it makes a circle. Circular path at the top. It makes a circular path at the top. Understand? So this path is clockwise or anti-clockwise? Okay, anti-clockwise. Okay, so I can write my direction already. My direction of magnetic force is the upwards, and then showing in the diagram already. And then the path is a circular path. But moving anti-clockwise. Yeah, and anti-clockwise. Okay, anti-clockwise. So that's all for this about these directions. I hope you understand. Okay. So that's all for this question, for this part. Okay. And thank you for watching. Okay. Hope you understand. See you. Bye.